And welcome to another 60 minutes of .NET Entertainment. I'm your host this week, Cam Soper. I'm here with my co-hosts, Maira Wenzel and Frank Boucher. We would like to welcome this week's guest, David Real.NET Dave McCarter. Hi, David. Introduce yourself and tell us a little bit about yourself.
Hey, everybody. I'm back for a second time. I'm really excited about this. I'm David McCarter. I'm Microsoft MVP. I run dotnettips.com. You know, I go all over the world speaking at conferences. I write books, blah, blah, blah. Most of the stuff I do now is either architecting or helping companies out with their code performance issues or code quality issues. So last time I was on, we talked a lot about code quality and things like that. And so this time, I'm excited to speak about code performance.
So I was checking out your blog, and it seems you're a musician, and you've got quite a few bands that folks would recognize that you've worked with.
Yeah.
Can you tell us a little bit about that real quick?
So, you know, I've been a musician for a really long time, and also an award-winning photographer, and so. One of the things that I really enjoy doing that I don't get to do as much anymore, but I still try to, is do photography for bands when they come into town. So there's lots of bands like Queensryche and Jeff Tate, the former singer of Queensryche, a bunch of other bands. You know, when they come into the town, they call me and said, "Dave, come do photos." I'm like, okay, you know, and so
awesome.
Yeah, and I'm really proud that one of the awards that I won, and two of the awards I won, is the largest photography contest in California, and the two I won from that were both of musicians, which you know, at these contests they don't really like shots like that. But that year I won third place and honorable mention. And one of the shots was from a singer from Los Angeles. The other one was the guitarist from Styx, Tommy Shaw.
Nice.
And I've always been a huge Styx fan. And one time, it was actually Valentine's Day, they were playing here at the House of Blues, and I got this really awesome shot that won an award. So
when I was like 11 years old, you know, my dad had a friend who had some teenagers, and one of the teenagers was done with their 8-track player, and so my dad's friend gave me the 8-track player and a few 8-tracks, and one of the 8-tracks was Styx, and I forget the name of the album, but it's the one with the robots on the cover with Mr. Roboto.
Oh yeah.
It was a great album. So
can I say I'm an award winning if I won a contest at Microsoft, like a second place?
Yeah.
I mean, no one will question you on it.
You got to promote yourself, right?
All right, no, but we're here to talk about performance improvements in .NET.
Yeah.
So, and you told us before the show started that you were gonna quiz people, or you're gonna do something interesting. So let's see.
We're gonna play a game, and we'll get into that in a second. But you know, if the one thing I really wanted to talk about this time, and of course this is because I just put out a brand new edition of my code performance book at the beginning of last month, and I worked really hard on that book, like over 6 months, and quite frankly, it was delayed because one of the things I really tried to do this time, a little harder than I did the last few times, and that is try to test all the different ways you can do the same thing in .NET. Because .NET's been around for 23 years now, over 23 years, if you go back to the beta days, and there's so many different ways of do pretty much the exact same thing, right? And, we get, the other thing I'm going to focus on today is collections, because you can get a lot of improvement if you change the way you do collections. And we have so many different collection types now too. So which one is most performant? If you're really trying to eke out the best performance without spending, days and days trying to figure it out, what's the best collection type, to use for that? And so, and that's kind of what the book is all about. The book is to show you all these different things and to kind of guide you into trying to find, get you there faster, the most performant way of doing something. Because, if you want to go to the slides, or not my slides, I can't do my slides, but my graphic, and that is, the user experience has always been, super important for performance, right? Even back when I started programming, users were important because, if you upset the user or it takes too long or, they can have a context switch, stuff like that, they're not going to buy your product. But now, with the cloud and most things in the cloud, you get charged on execution time, right? So, if you can, eke out a little bit more performance, especially if you're doing something thousands or millions times a day, that can really add up to savings, and to share a quick little story, I've heard stories about, people straight out of CS degrees going to Facebook and making, $200,000 a year, right? And I was going, that's crazy. Why would you give a 20-year-old $200,000 a year? But so it just so happened that the young woman that I mentor, that's what happened to one of her friends, and so we talked about it, and she told me the reason was because they hired her friend at least, to get better performance out of Facebook services and everything, right? And Facebook, views that, if we pay this guy $200,000 a year, but he saves us millions of dollars a year, right? It's totally worth it, right? And so that's kind of what I always think about now. Whenever I code, I always try to go, okay, is this the most performant way I can do it without, taking a lot of time to figure it out, right? So that's why, performance is critical for two big reasons now. And that is not only the user, right, but also execution time to save money in the cloud, because, everything's going to the cloud. Someday, pretty much everything will be in the cloud, right?
Oh, for sure.
Yeah. We'll have some stuff on premise, but I would say most everything is going to be in the cloud in the future, right?
Yeah, I think there's still a need for the on-prem in some cases, right? Very specific cases, but I think that's where we're heading.
Yeah. And we'll have hybrid, but more and more is going to the cloud, because the cloud is, if you really use the cloud for what it's meant for, you can get so much better performance, using the cloud services like Azure, right? So,
and one of the users is talking about using Visual Studio for slideshows, which we talked about before. This is very creative.
Does he like it or not like it?
Yeah,
yeah. Well, maybe someday we'll do actual presentations in the cloud, but in Visual Studio, but because I only have one monitor, I kind of had to whip this up really quick. So before we get to the game, I want to say that, last time I was on the show, we talked a lot about code analysis, right? And I'll talk a little bit about that at the end today. So code analysis is super critical, right? Whenever, you build, you should be running code analysis. Whenever you build on, in the cloud or something, you need to do code analysis, right? The other thing is super important to all of us, which I don't see done well enough or at all sometimes, and that's unit test, right? To me, the first thing you have to do is unit test to make sure your stuff is working properly and so it doesn't break in the future, right? So one of the things that, I've been harping, the .NET team and Visual Studio team ever since .NET Core came out. When .NET Core came out, they dropped IntelliTest, right? Which I actually worked with the PM for a couple of years with him for that. And they did move it to .NET Core. So we haven't had IntelliTests since .NET Core came out. So which to me hampers, doing unit tests. So the cool thing that I discovered recently, especially after, the announcements at Build a couple of weeks ago, is Copilot is actually pretty dang good at writing unit tests, right? And I'm going to show you a really quick example. So I have this method over here called add first. And I should have unit tests on it already. Yeah, I do. But I want to ask Copilot to write unit tests for all code paths. And so that's all I do. I just put in a prompt saying, write unit tests for all code paths, press a button, and it goes, sure, I'm thinking about it. And then in a second here, it'll come up with the unit test. And it's going kind of slow today, Monday.
And you're streaming live.
Yeah, and streaming live too. Yeah. So you can see there, Copilot just spit out the entire test unit to test the positive, negative, all that kind of stuff. I still need to investigate that it's properly doing all the code paths, like IntelliTest used to do. But Copilot in just a couple seconds will get you there pretty quick. So. I think that's a great, Copilot. I'm using Copilot more and more, especially for unit tests. And, when I have a couple minutes, or a half hour or so to, I don't have anything to do, I go to my open source project, I find some methods I don't have unit tests for, and I just start running Copilot against it, right? It gets me there so much faster. But don't blindly use the unit tests. Make sure you check them, right? Because AI is not perfect, believe me. And so anyway, so unit tests are critical, of course. And then, something I'll be talking about today, because I'm going to be showing you analysis, is benchmark tests, right? And so if you're really looking at performance, you really need to start writing benchmark testing against your code, especially before it goes out to the public. And I don't see this done. None of the projects I've been on, people do this, right? And there's actually been some projects on that I wanted to do it, but they took it out of the schedule. And so I would do the benchmarking on my own time, because that's how important I think this is, right? And especially if you're trying to eke out the performance. And I'm going to kind of show you some of the stuff I've been doing the last few months or so after I was done with my book. So,
and do you have any any library or something that you like for benchmark tests?
Well, yeah, I'm going to talk about that at the very end. But yeah, I use BenchmarkDotNET, just like Microsoft does. Okay. And my computer, especially when I was working on the code performance book, was running benchmark tests every night of the week, every night for months, right? Because I was trying to find the best way of doing things. And my benchmark test takes many, many days to run. So I can never do them all at one time. I have to do them piecemeal because it's just too long. Mm-hmm. So let me find the slides. And I don't know why this properties thing comes up every time I want to look at a slide. But anyway, so I want to play a game. So let's play a game. I'm going to ask all of you and the audience. So the audience, make sure you're ready to type in the chat window so we can get your answer. I'm going to be showing you different way of doing things in .NET. And I want you to tell me which is the most performant way of doing it. And this is all based on .NET 8. And so before I start with that, I want to say, .NET 8, there's huge performance increase in .NET 8, right? If you just move your code to .NET 8, you're going to get perf increase, right? Just like between .NET 6 and 7. Now, between 6 and 8, right, there's huge differences between performance. Most everything has gotten better. There's a couple things that slipped, but most everything has gotten dramatically better. And so,
should I have Steven's blog posts on the side here?
Maybe so. So I wanted to start off with something. Whoops. What happened? Oh, I hate it when Visual Studio does. Oh, there we go. Okay. So I want to start off something simple. Something simple that we do all the time is checking whether a string is valid. It has something in it, right? It's something very important to do. Whenever you get input from the user, you need to make sure there's actually something there before you start working on it. Because if you start working on it and it's null or something like that, you're going to be causing exceptions, right? So there's 5 or more ways of doing this in .NET. So out of these 4 ways I'm showing you here, is null or empty, is null or white space, using null coalesce. I can't pronounce right today. Null coalesce, and then pattern matching. Which one of these 4 ways do you guys think is more performant?
Are you asking us or?
Yes, I'm asking you, and I'm asking everybody watching.
I use the first line, and I feel, because for me it's clear, but I feel like the third one is the fastest.
I think the third one's probably the fastest, because and so I'm not much of a .NET internals person, so I'm kind of guessing here, and I'm kind of inclined to use my phone a friend because I see David's in the audience. But I think, because I think we can assume username is a non-nullable string at that. I don't know, but I'm going to guess
it's a non-nullable string. Yeah.
Okay. Yeah. I'm going to guess the third one, like Frank did.
Yeah.
Yeah. So, I typically use the first one too, and and the fourth, even if it was fastest, I don't think I would use that because it's so unreadable.
It is. It's not very readable, right?
No.
So to tell you the differences between like .NET 6 and .NET 8, I'll tell you in .NET 6 and 7, is null or empty was the fastest, right? But things have changed. And so you can see here, right, that null in quotes, which I tell people never to use, is null or empty, and pattern matching is all the same speed, right? The null coalescing is slower. Using null and empty is slower, and then is null or white space is always slower, because it does more checking than everything else. But you can see those 3 ways. Now we have 3 ways that are basically the same performance, right? Which we haven't had before in .NET, right? It's always been one was really different than the others. Let's see what people say. Lower is better. Yeah, lower is better.
There's a lot of 3 and 4 in the chat.
Yeah, some people were saying that it's like the comparison was a little bit tricky because it's like they're not actually doing the same thing.
Yeah, they're not doing the same thing, but I was just presenting the different ways you could do that. I've seen people do it or tweet about it and things like that. That's one thing I do is, because I do analyze so much code with these contracts I work on, I see all the different ways of people doing things, right? And then I also pay attention to Twitter to see what people are doing on Twitter too, right? And so that's what I present in the book, and what I'm going to be presenting to you guys is all the different ways I see people doing things. And
I like Morton's comment here. Like if we assume we don't care about white space, like you treat it differently or something. If they're all the same performance, then go for the more readable one, right? So,
yeah. So I would stick with this null or empty. It's always been the fastest. So I would just stick with that, to tell you the truth. And I just like it. It's just been around forever in .NET. So.
The thing that I noticed is that David didn't answer. I'm a bit disappointed.
Okay, let's go to the next one.
David Pine on the chat.
Yeah, David Pine.
Let's make it clear.
Yeah.
Make sure you feel like I'm pointing.
So let's talk about serialization, because this is something, again, that's done constantly, especially, you know, if you're sending data models across the wire and things like that. You know, there's we're doing JSON serialization all the time now, right? Even if you're using Cosmos DB, that's JSON everywhere, right? So forever, you know, we've had the Newtonsoft library, right? With Newtonsoft has been downloaded over 1 billion times, right? It's crazy, right? James Newton. And so, but then, you know, I forget which version of .NET. .NET decided to put a serializer in the framework itself, right? And so we have the JSON serializer. So when serializing a person object, I'm going to be actually showing you this model a little bit. So the other thing I want to say is, you know, when I do all these benchmark tests, I'm testing with what I call real world objects, right? I'm testing with person objects and things like that, right? I'm not testing with an array of integers. You know, I don't do many tests like that, because I write business software, and so I want to test with real world kind of things. And so this is a person object. Again, I'll show you later. So out of these two ways, which one do you think is more performant? The Newtonsoft?
I would vote for system text JSON, as someone said. We hired James.
Yeah.
Worked on the new libraries.
Right.
I know that we're constantly improving that library. So I'll vote the system text JSON, the first one.
Yeah, and it looks like the audience is pretty well settled on that one too.
Yeah. We kind of all agree that it's the first one.
Yeah, and you're all right. You can see here, in all cases, so the other thing I do, and I'll talk a little bit about this in a second too, is I test with different types of classes, right? So I always test with record type, reference type, and value type. And for the person object, I'll be showing you later, they're all basically the exact same thing, just different class types, right? And you can see across the board, Newtonsoft is much slower, right? And it allocates over twice as much of memory, right? And so the other thing we have to worry about is not only performance, but the memory allocation, right? So you can see it's a lot more memory allocation. So all of you using Newtonsoft, stop. You know,
yeah, we've been converting like all of our projects. Yeah. That's like, I think I have 2 left, but yeah.
So I will say that, you know, Newtonsoft, because it's been around longer, does have more features than the serializer in .NET. And so if you need those features, I guess you have to stick with it. But in most everything I do, the .NET serializer works perfectly, right? So, but wait, there's more. So if you want to eke out a little bit more performance, right, you can actually use a source generator. And you will get a little bit more performance out of it. And I'm going to show you. So this is how I set up the JSON serializer context in my testing library. And I have two different things here. I'm setting up a JSON serializer context for a person, and then I'm also setting one up for a list of person, right? And in a partial class, of course, because that's how source generators work. But if I just do that, and then to use it, there's hardly even a code change. To use it, you just do that. You just do serialize, but then you give it this parameter of person JSON serializer context.default.person, right? And that basically helps the serializer serialize things and deserialize things faster. And so if we look at the results of this benchmark test, you can see here that using the JSON serializer context is 1.58 times faster in this case. So just doing that, which just takes a couple minutes, right, you can get a little bit more performance. It's not a huge increase, but it's something, and something adds up if you're doing it thousands or millions of times a day, right? So I guess the moral of this story is that if you're serializing JSON, you should be using, if you can, use the JSON serializer context, right, to eke out that little bit more of performance.
And so just to like reiterate what you're covering here, so Fullsnable is asking, so is this serialized help by SourceGen now? And SourceGen means no reflection.
Yeah, no reflection, right? And that's how source generators work, is it basically gets rid of all the reflection, right? And I'm going to be talking a little bit more about it in upcoming slides too, but as much as I can, I use source generators if I can, and I've dedicated myself to write real good articles. I've done most of them already, of all the generators that come with .NET. So I explain them a lot better than Microsoft does. So let's go to 11 now.
And Johan was also asking, this is a requirement for EOT as well, right?
EOT?
Ahead of time compilation.
Yes. So let's talk about this. So I was going to start off with this one because you're probably not going to believe the results of this, but you know, one of the things I've been thinking about a lot, you know, during this edition of the book and then afterwards, is there's lots of ways of iterating over collections, right? There's many different ways of doing it in .NET. You know, the most common one, you know, I think is, well, that's been there forever, is for, of course. And then we have for each also. And for each, most of the time, I think people decide on it because of just personal preference, you know, more than anything. Some people like for better. I like for each better. It's just easier to set up, you know, and use. Sometimes you have to use for, depending on what you're doing. But so, you know, one of the things I test in my benchmark tests is all the different ways of iterating through different collection types, right? And to try to find the fastest way of doing it. And so I'm going to ask you all, if you're iterating over a dictionary using for or for each, which one of these methods is the most performant?
I find the second one more readable, but I don't know, if in the end they would perform just the same.
Mm-hmm. You say the same?
Certainly, I know I have a preference for the second one because of the readability.
Right, but is it the fastest? You know, we like it because of readability, but is it the fastest? Right.
I think it depends on the object you're iterating through.
Could be.
It does.
But all these I use the for each if I'm like using like a list or of a collection, and for the other stuff I will do like a for.
Yeah. Okay, so what's everybody else saying? Span for each. We're going to be talking about span. Don't worry.
We had a couple of people, including Morton, say, "Well, it depends." And specifically, it depends on the implementation of person ref dictionary.
Yes, exactly. But you know, all these tests are using the exact same type, right? So,
people are more going for the second one, though, I feel.
Yeah, more votes for the second.
Yeah, and the one thing I'll talk a little bit about in a little bit too, also, is that, you know, different types work. Different types, meaning record type, reference type, or value type, act differently, right, when you're iterating over them. So you can see here, for each is 337 times faster. That's huge. So all of you out there using .NET 8 and using dictionary, stop using for.
Okay, so for each is more readable and it's faster. Okay.
Yeah,
it's good.
Look at the allocations. Look, it's hardly any allocation to do for each, and it's big allocation to use for, right? So not only are you know, much more performant, but you're using a lot less memory too, right? And so in the case of dictionary, this is, that many times? The other thing is, when you run benchmark tests, it's not running it once. It's running it millions of times sometimes, right? And so it's the aggregate of all that. That's why my tests take so freaking long to run. I have one project I was running last night for my open source project that takes, just one project, benchmark test, takes 14 hours to run because I do all this crazy testing. So let's go to the next one. Stop me if somebody says something interesting. So now that we're talking about dictionary, right? And this is something I've been doing again the last month or two, is we have many different dictionary types, right? And of course they're all used for different things. But if you're just looking at the most common types, which is dictionary, frozen dictionary, immutable dictionary, or read-only dictionary, right? Which one of these are more performant, right? Because if you look at the description of frozen dictionary, I have it all written down here. It's an immutable dictionary if you guys haven't used it yet, and it can't be modified. And according to Microsoft, it can improve performance, right? But some of the other ones, they claim the same thing, especially like the read-only dictionary. So one of the things I've been doing is, when I use a dictionary in my open source project, I go, okay, that's dictionary. So now let's test with frozen dictionary and see how that works. Okay, let's test with immutable dictionary and see how that works, right? If you're just iterating, I'm asking not for creating these types, it's just iterating over these types. Which one of these four dictionary types do you guys think is fastest?
Well, since you put that caveat on there, not creating. Now, I've never used frozen or immutable, but over in Twitch, my friend Space Shot just pointed out. I don't know if Space Shot, but I'm calling Space Shot my friend. Anyway, Space Shot said you pay upfront to create a frozen, so the more you use it after that, the more you'll gain.
Yes.
And that sounds reasonable to me. Like I said, I've never used frozen, so I'm just guessing.
Yeah.
Yeah, I would vote 3 or 4. Like my vote would go towards
immutable or read only.
Yeah.
Some people are picking 4. Some people picking 1. One person picked dictionary.
It's all over the place with this one.
Yeah. And I'm trying not to explain things to give you the answer, but I think sometimes I kind of do.
I said I am terrible at quizzes, so
I'm terrible at quizzes too. I hate them. I hate taking tests, especially when you're looking for a new job. But anyway, if you're just looking at these 4 different collection types, you can see frozen dictionary is 3 times faster than dictionary, right? So if you can use the frozen dictionary, especially if you can keep it, like in a field or something in a class, you're going to get a lot better perf than using dictionary, right? So, so that's something you can look at if you're trying to eke out a little bit more performance. What? Somebody say something funny?
Yeah, no. Oh. So they're saying that Morten is spoiling for everyone because he's giving good answers before the end. You show the benchmarks.
Yeah. Don't give it away. It's got to be a surprise. Okay, let's.
I'm surprised there's so much difference with the. What was the last one? It was the immutable.
Immutable dictionary. Yeah.
I'm surprised it was like a lot.
Yeah. And that's the thing I've been working on is, I would think immutable is faster, but it's not. If you're just iterating, right? So I mentioned before that all these tests I'm showing you, I'm using this person type. This is the person type. This is the model of the person type. And what I've done 2 things in my open source projects. One is I have a testing project now that, the person objects are in it, coordinate objects, it pre-gens, all this stuff. So I created an assembly you all can use to do benchmark test or to do unit tests, right? So I've spent a lot of time on this, and this is what I use, and you guys can go to my website and check it out if you want. But one of the things that I discovered in one of the previous editions of my performance book is, you know, different types actually iterate differently. And so out of reference type, value type, and record type, out of these three different types, which one, if you're iterating, you know, through a list, which one do you think is more performant?
I haven't read about record type performance to see.
Yeah, if I'm thinking in terms of just reference or value, I'm going to go with reference. But yeah, record type throws a monkey wrench in it.
Record type is also newer, right?
Yes, it is. Yeah, it was added in .NET, what, 5 maybe, or 6? I forget.
Oh, that long? I thought it was like more 7 or something like that.
No, it's been around for a while. Yeah, 5 or 6, somebody said. Yeah, 5 or 6, I think. What's everybody else saying? 2 value type? 3?
Some people are saying 3, 2.
Yeah, people are picking everything, right?
Yeah.
So let's look. You can see here, reference type is by far faster, right? If iterating through it. And no allocations, right? The other two have allocations, a lot of allocations, right? So you can see the record type is 7 times slower. Value types are 12 times slower, right? And so if you're really trying to eke out performance, I would stop using value types, you know, because they're dramatically different. And I've talked to Mads Torgerson about this, and you know, but they are different. They're going to be more. They're going to be slower. That's just the way it is. And so, I really like record types, you know, because it pre-gens a bunch of stuff that we don't have to worry about anymore. But as you can see, you know, reference types are faster, right? In this case, in this test, reference types are faster. So
is there conditions where, like, are there cases where, like, for each the reference types are faster, but in other cases the performance could be the same or faster?
In .NET 8, they're pretty much different, right? In .NET 6 and 7, record types and reference types are really close to the same speed. Record types ended up being a little bit slower, but you can see here they're a lot different in .NET 8, right? And you know, that's kind of what I wanted to focus on in this talk is these kind of differences that have come up in .NET 8. So some things in .NET 8 have wildly changed, and some things have gotten really close to being the same, right? And that's, like, again, that's one of the things I've been, you know, researching a lot about since .NET 8 came out.
I feel like the chat is are saying giving a lot of love for records. So I'm not sure if that one people will change their habits.
I
like records.
Yeah, I love records. I really do. I try to do most things now. If it comes down to a data model, I do all my data models in records. Yeah. You know, there's different ways of iterating through a collection. Like I said, you know, there's 4 for each, you know, that. But there's also other things you could do, and I'm going to go through these really quick. So this is one way you can create a collection using the memory extensions as memory. So it turns it into a memory object instead of the normal object, right? So, and this using for each. You turn it into a span and go through it. So you can use as memory. You can also use as span, memory extensions as span, right? Which turns it into a span. And spans are, you know, a newer type in .NET, and they're really fast, you know, iterating through them. There's also, you can use memory marshal create read-only span. So we also have, not only do we have span, but we have read-only span also, right? So you can use memory marshal create read-only span, and then I have to go down because it doesn't sort the way I want it to. And there's also memory marshal create span, which creates a span. So out of those different ways of showing you compared to just going through a normal list, which one of these 5 methods do you think is faster?
Maybe the read-only span.
Yeah, I'm gonna say 4.
4, okay. Anybody else?
Yeah, that's what I was voting for, but I was like,
right?
Mm-hmm.
Going through, I don't know. We'll go with, what did
3,
you say?
2.
I'll go with the.
Yeah. Some people are saying 4. Yeah.
I'm just thinking I never wrote iteration over a collection using any of the 2 to 5 methods. So never done that way.
So, you know, if you gave me this list, and of course I know what the answer is, but if you gave me this list, I probably would have said, yeah, create read-only span, right? That seems like it will be the fastest, right?
But it's
but it's not.
About where they show that during build. Like they were optimizing the code. I forgot what the title of it. I think it was.
Oh, the one with Steven and Hanson.
Yeah.
Yes.
Yeah. So in this case, right, in this test, you can see just using a list is faster than the other ways, right? And it's not hugely faster. It's 1.616 times faster. And it doesn't allocate anything, right? When the other ones do allocate.
So I create code 16 times faster, and I didn't know about it.
Yeah.
Okay, so list is still the most performant.
In a for each, if compared to these other 4 ways of doing things, yeah, it's faster.
It means like the compiler is doing a great job as optimizing our code.
Yeah, and they've done a lot of optimizations, you know.
I like Cam's here because I was thinking the same. Like I never used those methods, and I'm glad.
But like I said, you know, there are things in my open source project that I've tested all these things, and sometimes span is faster, right? It really depends on what you're doing. And so I want to make sure that's clear that, you know, what I'm telling you here and, you know, what I write in my book is just to guide you closer to the right answer than you going through all the work that I do, you know?
Yeah.
So, you know, I mentioned earlier, there's tons of different collection types in .NET, right? So out of these are not all the types. I couldn't really show you all the types in one slide, but out of these types, different types in .NET, collection, frozen set, hash set, you know, etc. Out of these 10 types, is there 10 there? Yeah, there's 10 types. Which of these 10 types do you think is more performant using for each and a reference type?
Yeah, and just to clarify, because some people were confused, the performance using those in a for each, not the for eaches.
In a for each, right? In a for each.
We talked about for each before, but
yeah,
I will go with collection. I think they did a work in optimization, thinking a lot of people are using collection. Let's make sure that one is performant.
Right.
So we'll go 1.
Who's
Who's with me? And then I will be.
Collection sounds good. Span. I'm thinking span because they're doing a ton of work on span. So.
Yeah, they are.
Yeah, I mean, my inclination would be to say span, but I learned my lesson on the last question. So
yeah, exactly. No votes for linked list.
Ash could be like.
How many people use linked list? I've never seen anybody use linked list, to tell you the truth.
I have seen it used, but I couldn't tell you why.
Yeah.
So people.
Some people do in the chat. Yeah, some people use list, which is not here.
Well, yeah, and list too. List versus it's list versus other collection types, right? So.
Yeah.
Right. So yeah, I'm going to be showing you list compared to these 10 different types. Yeah.
Mr. Pine, 0 is not a good answer.
Zero's not
an
a good
array.
Answer.
Morton also said 0 array.
So so let's look at this. The chart's a little bit harder to read because there's so many different types there. But as you can see, in this case, immutable array is 1.36 times faster. Right? So the reason, one of the reasons I wanted to show you this, comparison is this is some of the work I've been doing, since my book came out in my open source project, right? I'm going through everywhere I use collections in my open source project. I'm going, okay, what's the best way of iterating through this, and what's the best collection type I could use to eke out some more performance, right? Because I want to make sure that everything in my open source project is as fast as possible, right? So people
Dave, since that image is, like you said, there's a lot of information there, and like I had to really like squint to see what was going on. Could you just read through which the 1, 2, 3, 4, 5, 6, 7.
So the first one's immutable list, immutable array. I'm sorry. The second one, which is not too far different, is linked list. I was really surprised about this when I saw this. I go, linked list is almost as fast as immutable array. And then you have list, right? Which is a little bit slower than those two. Then frozen set. I'm actually finding, I went through my project and I changed a bunch of stuff to frozen set and I ripped it all out. Because you can see here, it's not as fast. And then read-only collection, and then hash table. So right now,
and I being the less performant.
Yeah. And so actually last night I ran all the benchmark tests for my open source project because I've been doing this process of going, okay, let's try frozen set. Okay, that's not as fast. Let's try span. Okay, let's try immutable array, right? And so I'm changing all these things in my open source project to eke out, the most performance as I can.
So in this particular test, did span not even make the list?
Yeah, I actually had to lop it off because it was getting too big. Yeah. So it was on it, but I took it off because it was slower than these methods. Yeah.
Yeah, so the other ones that are not showing on this list are even slower.
Yeah.
And David has a question about, do you have a link to all these tests so that the viewers can read the source, understand how you test them?
Yeah, if you go to my Spargine project page, you can get a link to that. Yeah. And if you go to .nettips.com, you can find it on there. Yeah. Okay, what's the next one? I'm forgetting now. Oh, okay. So that's all the quiz. That's done for the quiz. So no more testing, Maria. I know you don't like tests.
I can relax now.
So to end up with, one of the things I wanted to talk about, because I can't talk about everything I want to in an hour, right? But one of the things that I did show you was the source generators, right? So in my open source project, I've changed all of my regex to use a generated regex source generator. And this dramatically improves regex. And so I know we all don't like it, because we don't like the syntax, but it really can give you better performance, right? And especially if you use the source generator, you get much, much better performance because all of that reflection is pre-gen, like we were talking about earlier, right? if you use a string builder, and you all should be using a string builder, right, to concatenate strings, you can actually get better performance if you use the string builder from an object pool, right? So there's an extension to turn string builder into an object pool. And if you do that, you actually get better performance with string builder. It works just like normal string builder, but you use it from an object pool. So object pools can really save you some performance. So that's a good thing. Also, you know, ever since the beginning of .NET, we've been using the type called random to create random numbers, you know, stuff like that, random byte arrays. But stop it, because there's a newer type called the random number generator that is much more performant than random, right? So if you're using random, change. You'll get better performance. I don't like regex because of the madness. Madness, yeah. The other thing is logging, right? Logging is super important, and logging in applications is something I see people do not near well enough, and sometimes not at all, right? And I was actually working on one of my recent contracts, and they took out most of their logging because of the performance, right? But if you use the logger message source generator, you dramatically change the performance of logging. It's dramatic. And so if you're using logging, you better be logging. You should be using the logger message source, because it really gives you a lot more performance. And it's really easy to use. All these things are pretty easy to use.
So a lot of people also use like a string interpolation with logging, and then it's like it really causes some performance issues there too.
Yeah, and this is covered in my book, is that, you know, there's some places where you don't want to use string interpolation because it does slow down things, especially in logging. It actually does slow down things in logging. Yeah. Yeah. So basically, you know, all the things I've been talking to you about, you know, how I test. I even have is in my Spargine open source project, right? And so I talked a little bit about, you know, I had this testing NuGet package you can use to do. That's how I generate all these objects and collections and things like that. You know, it's from that NuGet package. And the other thing I did, I think around the second version of my book or something, is I created a benchmark NuGet package too. That uses BenchmarkDotNET that basically sets up these projects it sets up your tests exactly the same way I do it. And I have a long article on my website to explain exactly how I benchmark. But I've wrapped all this up into a really easy to use NuGet package to help you, you know, to do benchmark tests easier and kind of like the same way I do it. So if you go to that link there for Spargine, you can get all that information there. What else did I want to talk about? Oh, the other thing, and we talked a little bit about this last time, is .NET has a bunch of analyzers for performance. I don't think there's near enough, but they do have some. And so if you go to that link there, that'll take you to my editor config, which is probably the biggest one known to mankind, because I've literally done many hours of researching all the different things you can put in the editor config, because Visual Studio doesn't do it for you. And so I have to painstakingly do this every quarter or so. And but anyway, they're in my editor config. And so if you want to immediately show at least everything that there's current analyzers for, you just plop those settings into your editor config, and it will instantly tell you where your performance issues are.
All the knobs.
Yeah. So you can do that. And we did talk about this early on, but everything I benchmark, I use BenchmarkDotNET. BenchmarkDotNET is the same package that .NET uses to test .NET. And and the guys there are really a lot smarter, than me, when it comes to benchmarking, of course. But if you're going to do benchmark tests, don't roll your own, please. I had to before BenchmarkDotNET came out, and BenchmarkDotNET is so much better and so much easier to use. Like I said, it does take time if you're doing lots of tests like I do, but the other thing I want to say real quick is that, I've uncovered issues that in benchmarking that didn't show up in unit tests. So there have been a few things that I've had to change in my open source project because they broke in the benchmark tests, and I had to go back and fix them. So benchmarking will uncover more issues in your code too. So, one of the things I've been trying to do kind of religiously now with my open source project is that anything I write first gets a unit test and then gets a benchmark test. To at least, set the baseline, for everything, and then go forward from there when I'm doing testing and trying to figure out things. So, so that's it. I just kind of wanted to leave you with, if you guys were going to ask me to promote something, there it is. So my brand new code performance book is out. It was out beginning of last month. And then I also have my coding standards book that I put out a brand new version at January 1st. And then around this time last year, I put out a new version of a new edition of my Surviving the Technical Interview book too, which if you're looking for a job, you need this book.
Congratulations on all the releases. Thanks.
I work hard on them. Those of you who have never written a book, it's not easy. Especially even when you're doing it by yourself, like I do, because I self-publish.
Our other co-host on this show, David Pine, recently wrote a book on Blazor, and I told him up front, I said, good luck with that, David. And yeah, very much. He has reported that it was a lot of work.
Yeah,
it's a labor of love, right? Like it's for you sharing the knowledge with the community. It's not for financial. It's not the financial aspect that makes it worth.
Well, I can tell you something, and I don't say this publicly very much, is that, towards the very end of writing a book, every single book I've written, and I've been writing books since the 90s, right? I go, I'm never writing another book again. This sucks, And then literally a day or two after it's released, I go, okay, what's the next book I want to work on? When will you learn your lesson, Dave?
It happens. I think with all the authors, right?
Yeah.
All right. That was awesome.
Yeah. So let me do this. So I guess we'll wind it down there. We've let Dave. I was going to ask Dave to talk about his book, but he just did talk about his book. So go buy Dave's new book and make it worth that labor of love for him. Thank you, everyone, for watching on .NET Live. Please check out our other great .NET live TV streams and videos at .NET Whack Live. And tune in next week when we'll have, I think he's an MVP. I wouldn't swear to that, but we have Sean Wildermuth joining the show. We unfortunately, due to a software glitch, we have no idea what he'll be talking about, but we'll sort that out before we go live.
But it's for sure it's interesting.
Yeah, for sure it's interesting. So we look forward to seeing you then. And yeah, come back and see us. Thank you so much.
Thank you.
Bye, everybody. Have a good week.
See you, everybody.